Good morning. Let me see. I'm from the Boston area, and as you know, the Boston Marathon is coming up soon. So obviously you folks are all prepared for it. You clearly are endurance runners, made it through the whole ARC forum. So I want to welcome you for showing your persistence and coming forward here. My talk is going to be, once again, a little different than maybe some of the others you've seen. I'm going to focus on kind of I'll say the downside aspects, if you will. But before I do, let me start with the good news, if you will. And you may have heard this, you may hear more of it in this session today, you may have heard it elsewhere. Building automation systems, I'm gonna go for a great definition of what they are. I assume that'll come up as well. But they provide all kinds of great benefits, as you see here. That's interesting, this monitor doesn't work anymore, that's okay. They provide greater energy efficiency, easier operation, improved occupancy. I actually read one report that claims that the employees are 37% more productive in a building automation system building. Okay, so there's a lot of great things about building automation, and it's increasing more and more. But they also represent enormous number and extensive opportunities for new cyber attacks. And as building automation systems become more widespread and cyber hackers become more aggressive, I often like to say, unfortunately, the worst is yet to come. So once again, I realize that many of you may be at the early stages of building automation, so I don't want to discourage you from doing it, but one of the things we've learned over the years from all of our research we've done in cybersecurity is one of the areas where you're most vulnerable is when a change is taking place. A new technology should be introduced, new procedures introduced, because you don't have 20 years, 40 years of experience. So all of the things you knew to be cautious about in the past, you haven't accumulated that, so you become more likely. So here's the other session here. Could you suffer a cyber attack? I don't know how many of you are in the building automation system industry? Okay, a few of you are. So I guess the obvious question is, one of the things we sometimes hear, and this also applies in operational technology in general and in factory automation systems as well. Often they say, well, I know all those terrible things going out there. I know there's a lot of bad neighborhoods, if you will, around. But we're in a safe neighborhood, primarily because we are air-gapped. But as many of you know, air-gap systems have been penetrated. Stuxnet probably was one of the earliest and most well-known examples of it. And so, and the second thing going on, and we see this in many of the other sessions you may have attended today, not just in building automation systems, but more and more there's need to connect to the internet. This is to allow you to do remote diagnostics, to allow you to integrate with your IT system for billing and for other purposes. It also allows the vendors who are providing more and more of the equipment to be able to monitor it. So more and more systems are not air-gapped, and even the ones that are air-gapped, there always are ways around it. So that's the obvious question I always ask people, do you think your systems are fully safe from being penetrated? Anybody? No. Now, once again, people may vary in their opinions. One thing, and I'm not sure if it was Larry or who I spoke to recently commented, that when you talk to people and they're honest about it, they say, well, there is a chance my system could be penetrated, could suffer a cyber attack. But what's interesting is often the second question and reaction was, well, what are you going to do if that happens? And usually there's like a blank expression because, well, I don't know, because we've never had to deal with that before. So the question is that you have to assume there is a chance, not guaranteed, there's a good chance that your system will suffer a cyber attack. So you have to change your mindset and say, let's assume that happened today. What is it you have to do? How do you deal with it? So I'm going to talk to you about some of those issues, if you will. The other issue I talk a lot about here, and I mentioned this in other people I met during the conference here, to my knowledge, and this is where I appreciate the other speakers may be commenting either now or during the panel session, there have been relatively few reported cyber attacks on building automation systems. This is a rhetorical question. Well, if you had a cyber attack on your system, why wouldn't you report it? Why wouldn't you make it public? Well, there's lots of reasons. The first reason I was told is you ask the lawyers, they say nothing, is the first advice you get from every single lawyer. But also you don't want to suffer reputation damage. You don't want to encourage copycats. You don't want to deal with all the legal complications that come out of announcing you've had a cyber attack. So the problem is getting detailed information on when cyber attacks happen, how they happen, what were the consequences, what people dealt with them is very difficult. I'm going to give you a little bit of information I've been able to gather, and hopefully many of you here could either share or contact me either here or afterward to give me more stories about it. Most of the reports that I have seen, I'll comment upon some of them today, are reports done by white hats. That is basically good guys who want to see, is your system secure? Let me go and rattle this, let me go and rattle that, and see what I can find. So in general, these are not such a real cyber attacks, but basically they have all the kind of key elements of a cyber attack. And of course, once this vulnerability has been discovered, hopefully soon, which can be measured in hours, days, weeks, sometimes years, that vulnerability will be patched and life goes on. So let me give you a few examples. One of my favorite examples, and once again, I appreciate my colleagues who have more knowledge than me. Allegedly, this is a hoax. It was not a real cyber attack, but it was reported. You can find it on TikTok if you want to. It's basically made a large office building into the world's largest video game. I'm not sure if you can see it here now. Basically, this is Space Invaders on a 20-story building. You know, you can see the bullets coming down and the shooters here and all that sort of stuff. Now, whether that actually happened or not, it technologically is possible to happen. If you take control of the lighting system for a building and you hook it up so you can remotely control it, you can control the individual. In fact, in the video, they actually show people at the window as the lights are going on and off. And once again, I'm not sure if it's a real event or not, but it illustrates the kinds of things. Not exactly the most destructive thing. Obviously, if you're trying to work on getting your annual report out and your lights are going on and off as the bullets pass by, that could be a bit distracting. Once again, done by a white hat, but this was an actual validated attack. There are many basically smart lighting systems of all various kinds. This would happen to be the Philips lighting system. And they showed how, what's clever about this, they combined a number of technologies. They actually had the cyber attack, because they had to be physically close to do this particular attack, but they actually had a drone fly from a mile away to the building, take control of the lighting system in the building, and basically turn it off. They were not clever enough to make it into a video game, so it's nowhere near as interesting a video to see. You just see lights flashing on and off more or less randomly. Not exactly building automation per se, but has a lot of the same characteristics, was it? I'm going from 2009 to 2016 to 2020, so these things keep going on and on. This was also a demonstrated cyber attack on the traffic lights within a city. So not exactly within the building, but the same kind of ideas. And it was kind of something I would really like. Not only could they turn the lights on and off, they could also time them so you get a green light all the time. That is a feature I wouldn't mind putting, having availability yet, if anybody's been through any kind of municipality, if you will. So those are some examples I've seen. Let me open for a second. Any of my colleagues here, anybody else, seen other examples of real live cyber attacks on buildings? Before I go on. Yes, go ahead.
I don't know if it's a building, but you know, the target hack went in through the HVAC system and laterally hit customers.
Exactly. The reason I wouldn't count that is because it really wasn't attacked on the building automation system. It was a case where they leaped, if you will, from the building automation system into the IT system. So it definitely, you know, in the broad scheme of things, it has that connection. But let me give you some I have come across. This is fairly recent. This is 2022. Cyber attackers took control of the lights, basically took control of the total building automation system, including the heating, the door locks in an office building. But let me do a quick digression, because I guess it would fall in a category of building automation, of much more limited. I believe I have not actually used the feature. In this hotel, I believe you can unlock your door from your smartphone. I know I've used that feature in the Hilton in New York City. I think it was like 3 years back, there was a hotel in Austria that suffered a cyber attack. And the cyber attacker changed the lock settings on all of the doors. Now the good news is you can still use the handle like you can here to get out. You just couldn't get back into your room. What was interesting, this now was 2 or 3 years ago, so I haven't seen the latest, but apparently in the aftermath of that, he switched back to manual keys in the hotel. So that's a case where someone said to me, the cavemen never suffered cyber attacks. So there's a question of how far back to the caveman age do we have to go to be fully safe. And what it shows here, this is some direct quotes. A technician called us telling us this was the building automation system company, got a call from one of the managers of the building. So the technician told us his building was completely locked down and he couldn't operate it. It even locked the building owners out. Now what happened here was there were certain features, and once again, maybe some of you know more about all the various features, but there's various features you can have in the building automation system to basically not allow updates to take place for it, or not allow change to take place unless you have a secondary password. But apparently they had never bothered setting that secondary password. But the hackers did. So now when they tried to regain control of the building automation system, they were shut out by the protection features that they had put into the system to potentially hackers prevented the owners from getting into their own system. I'm not sure if I gave the story completely straight, but just to give you an illustration of how things can get out of control. And what I just did. Okay. And I just came across an article recently about 2 buildings being hit in Finland. I don't have the details of those buildings being hit. So there are actual cyber attacks taking place. Once again, why are not more of them? Well, first, we don't know how many are actually being taken because they're not much reported. And secondly, if you will, there's what I call the low-hanging fruit. If you can steal a credit card number and make money off it, why not? Why not? But it turns out, as you've seen, the classic example I gave was the Colonial Pipeline executive who testified in Congress saying, well, we had never considered the possibility that someone would do a ransomware attack on Colonial Pipeline. That's like a building automation system company saying, well, I never considered the possibility of someone doing it so far. So these are kind of, maybe it won't happen today, maybe it won't happen tomorrow, but basically as they work their way down the opportunities to gain money, it's just yet another target waiting to be hit. Now, let me share you a little bit of research we're doing at MIT. And this is, I will not say we're doing a lot. That's why I'm anxious to learn more when I come to these conferences, if you will. But we are working with some of the standards groups on building automation systems and building management systems, particularly those who are interested in doing energy management, improving the energy efficiency. In this case happens to be apartment buildings they were looking at. What was interesting about this, we talked about cyber attacks in terms of disrupting things, but also they can be used as a way to deal with or invade your privacy. And this is an example of what they were able to do. They were able to tap in, once again, this is all done by white hats, so this was not an actual external cyber attack. They were able to tap into the energy management system of the building and looked at things. So for example, that there, I'm not sure what time of day it was, but that's you preparing your smoothie for breakfast with the blender. And over there you can see you're starting working. Imagine your boss having access to say, whoa, you said you were working at 9 o'clock this morning. You didn't turn your workstation on until 11 a.m. this morning. What were you doing those 2 hours? I see you had a long smoothie break. So the possibility of, in some sense, getting an awful lot of information of what's going on either at your desk, in your office, or at your home. Once again, good side, bad side, the energy management feature could take advantage of this to plan better, to know the better view of your energy demand. So there's a lot of, almost everything is a double-sided coin. Almost everything can be used in a very beneficial way, both to you and to your company and to the building, but also, if abused, could be invasive of your privacy. Another issue here is the issue of how bad can it really get? And this is my point I mentioned. If you take the assumption that, yes, you could be hacked. We don't know when, we don't know how, you could be hacked. How bad can it be? Well, if you shut down an organization, whether it be an apartment building or office buildings, building management system, that can be very disruptive. If the lights are all off in your offices, you can't get a lot of work done, particularly if you don't have enough sunlight coming in through. But it's really serious. I mean, I worry a little bit elevators, but I think elevators have kind of a mechanical brake on them, if you will. So I don't think you can say plummet you to the bottom. So most of these things can be disruptive, if you will, but nobody really gets hurt. But is that really the end of the story? Well, for one thing, of course, if the disruption lasted more than a few hours or a day or so, your business basically is shut down, you have to go someplace else, that could be very costly to you. But can things really blow up? Can people get hurt? Well, this is some of the area, once again, I work with a lot of different groups at MIT, the aerospace department, the power systems people. So we work with them on various experiments. So this is some of the things I want to talk about. How many of you are familiar with variable frequency drives? I wasn't. I'm glad to see you were too at one time, but I've learned a bit, if you will. So as you know, these are controllers that basically allow you to control the speed of a motor electronically, if you will. And of course, they're used in all kinds of systems, but particularly in building automation systems. They exist because they're often used to control pumps and fans. They're a key component with HVAC systems and so on. But most of the modern VFDs, or the VFDs today, are usually operating under software and firmware control. And we've actually looked at some of the software and firmware controlling VFDs. So here's one of the projects we did with some of our students, if you will. This is a typical VFD that they use in the power systems lab, where they allow them to play around with it and test and try various different things. I usually say the size of a bread box, but I don't know how many people have bread boxes in their houses anymore. But in case, you can imagine, it's a relatively small system, and it has these various capacitors. Typically, VFDs have series capacitors. We changed a few lines of code, which you could change, assuming you have access to the firmware of it, which you could have if you manage to breach into the system. And this is what it did. Now, we did it outside, okay? And this is an explosion outside of the power systems lab, section, if you will. Now, that was a toy VFD. What do real VFDs look like? Well, they come in all shapes and sizes. This is one shape and size. Someone actually offered to donate one to us, and someone was interested, would you want to explode it? We say, I don't know if I want to be anywhere near if I did. So we haven't done it. We don't know how big a mess it would make. Maybe someone have seen one of those go. But if you were to do the same kind of thing, change the software controls, do the various things that we did with that small test system, you could get a pretty messy situation. So that's kind of the concern I have. Now I want to kind of do one last thing before I end my talk today. Some of you may have heard me give this pitch before, if you will. We've developed an approach to analyze these types of systems we call cyber safety. And it's a clever term because cybersecurity is kind of almost overused. Cyber safety kind of combines the notion of being safe with your cyber, but it actually is very different. Safety, in most cases, is to prevent accidents from happening. And accidents are, hate to say the word, accidental. They're happenstance. And so the odds of an accident happening is, whatever the statistical probabilities are. But if it's done by a cyber attack, it can be deliberate. And when it happens and how it happens can be much more controlled, in this case, by the bad guys. So we want to study how do you analyze possible cyber threats. The approach we had is, number one, of course, was make sure you understand what you're trying to prevent. Like, I don't want this thing to explode. You'd be very clear about what your goal is. Then you say, and this is, I often made the comment, in the headlines, you'll often see the headlines say, this should not have happened. Well, then what is it that you would put in place to ensure that it did not? What controls did you put in place? So we say that everything that happens in your organization, including the firmware on the VFDs, but everything in your organization, whether it be computerized, mechanical, human activity, is a process. And for every process, there should be some controller that's monitoring the process to make sure it's behaving correctly. But that controller, if you will, is also a process, and there should be something that is monitoring that controller to make sure it's behaving. So we call this hierarchical control process in an organization. I won't go through all the details of how we use this analysis, but basically we developed this we call hierarchical control structure. To give you one last example, we decided to look at somewhat of a system that you would imagine finding within a building automation system controlling, and that is chiller systems. Because chiller systems, obviously to keep things nice and cool, sometimes a little too cool in this room, are fine. It turns out they're becoming increasingly important because many companies have data centers. And keeping your data center cool is a very, very important issue. Otherwise, your data center goes down, which is all kinds of other complications. So we wanted to see, what kind of vulnerabilities could we find in a building chiller system, if you will. And so we developed a hierarchical control structure for it. Once again, the print's too small to read. I don't encourage you to do so. But the point being, we said, what are all the processes? What are all the controllers? What are the controllers for the controllers, et cetera, et cetera, et cetera. a level of detail that a lot of people don't really go into, if you will. And if, for example, there's all kinds of things we came up with. For example, one of the things, as you probably all know, many devices that have motors in them, there are certain resonant frequencies. And what you do is you build your system, particularly in the software, to make sure you avoid the resonant frequencies so you don't shake themselves to pieces. Or if you kind of flip the software around, and rather than avoiding the resonant frequencies, you target the resonant frequencies, very messy things can happen. Likewise, if you reverse the rotation, various bad things can happen because many systems, once again, the VFDs can go backwards, but maybe that wasn't what they were designed to do, and the consequence of what the pumping is going on can be very bad. Also, you have to control certain settings in terms of pressure, in terms of temperature. If the lubricating oil isn't at the right pressure, the right temperature, it says, I've been told it can basically damage and destroy the compressor within minutes, and so on. So in case just going back one notch here, you may have noticed at the bottom, VFD explosion. We've already been there already, but you understand that idea. So the point we're saying was there are many different vulnerabilities within a chiller system. Once again, as white hats, we didn't try to blow up any chiller systems, if you will, but we basically demonstrated what would be the vulnerabilities that could do that happen. And we developed various attack scenarios over here of how you could override various parts of the control system and cause it to go basically off the wheels. Those are interesting. There's a paper we wrote and published about how to basically blow up chiller systems if you happen to be bored someday and you kind of want to give it a try, if you will. And some conclusions. In some sense, as I've said at the very beginning, and I'm sure many of you probably are here because you either are involved in or considering it, building automation systems have enormous advantages. I'm not the salesman. I'm sure they can tell you all the benefits, enormous benefits. But they do present all kinds of new opportunities, both good opportunities, but also dangers. They've been infrequent so far, but they're likely to increase as time goes on. So as you're considering and designing, building automation systems, you also have to keep in mind what are the possible things you need to be careful about. So those are some of the things that we want to discover, and I'll be glad to answer more questions probably during the panel session. I want my colleagues to get up and have their speech. Thank you.